All right, we're going to start chapter 11 today, and we're going to look at 11.1, where we use measures of central tendency and dispersion. When we talk about measures of central tendency, we're talking about finding the mean, the median, and the mode. Okay, the mean is the arithmetic average. Okay, when you average a set of numbers, you're going to add them up and divide by how many there are. We're going to find the average value of the data. Okay, when we find, so let's just do that for example 1. It's going to ask you to find the mean, the median, and the mode. So if I'm going to find the mean, which is the average, I'm going to take these numbers and I'm going to add them together. And when I add up this list of numbers, okay, when you hit equals, I get 2,182. Okay, that's the sum of all of those together. And then we want to divide that by how many numbers there are. So there's 1, 2, 3, 4, 5, 6, 7. So if I divide that by 7, I get an average of 311. So the mean is going to be 311.71, and we're going to round that to the nearest hundredth. Okay, this is the 10th spot, this is the 100th spot. So we're going to say 311.71, that's the mean value. Okay, when we find the median value, the median is the value that splits the data into two halves. One half is smaller than that number, the other half larger, maybe used for continuous or ordinal data. The median is the middle number, but you've got to order the numbers from lowest to smallest. So if I'm going to find the two lowest values here are 215, and it occurs twice, so I'm going to write it twice. Okay, the next smallest value that I have is 289. Then I have 296. Okay, then I have 351, followed by 390, followed by 426. Make sure when you list your numbers from least to greatest that you didn't skip any numbers. So I started with 7 values, that's why I divided by 7, but I should still have 7 values, and I do. Now, you have to order them from least to greatest to find the median. The median is the value that comes in the middle. Okay, so if I start on the outside and I cancel the greatest and the smallest, and I do it again, cancel the greatest and the smallest, cancel the greatest and the smallest, and you end up with this value in the middle, so that's your median value. You would say the median is 296. Okay, now, this happens to be an odd number of data, okay, and so there was one value in the middle. You may have an even number of digits here that you're trying to find the median to. So if you get to the middle and there's 2 values in the middle, then you're going to average those 2 values. So you would add the 2 values together and you would divide by 2. So sometimes your median value isn't actually in your data set. Okay, that will happen to you. In this case, the median is in the data set because there were an odd number of data pieces. Okay, so 296 is my median. And then the last thing you're going to be asked to find is your mode. And the mode is which value occurs most often. Okay, in this case, my mode value would be the 215 because it's happening twice. There's 2 of them, or there's 1 of everything. So 215 occurs more often. There are times with your data, if every number just occurs once, you'd say there's no mode, and you could have multiple modes. If there was another piece of data that happened twice, then I'd have 2 values that are modes. So you can have a variety of answers there for your mode. But there's one mean, there's going to be 1 value for your median, but you could have more than 1 value for a mode, or you could have no mode at all. Okay, that's how we do mean, median, and mode. Okay, now when it comes to the MAD, we call that the mean absolute deviation. Okay, let me turn the page on you here. So when we look at this page, okay, you're going to also ask you to find the mean absolute deviation, or the MAD. And what we're saying about that is we're looking for, first of all, we have to find the mean value. So if I take this set of data and I'm going to find the mean. So if you go back to that first page, how do we find the mean value? Well, we add these up. I'll take 505 and I'm going to add it to 510. I'm going to add it to 480. Add it to 550. Add it to 495. I'm going to add it to 500. And hit equals. I get 3,040. And I want to divide that by 1, 2, 3, 4, 5, 6. I get a value of 506.67. Okay, if I'm rounding that to the nearest hundredth, okay, we get an average of 506.67. Okay, I'm just going to go ahead and I'm going to round that off just for the purpose of this will go a little faster. I'm going to say that's 507. Okay, so I'm going to use 507 on that. Okay, so if the mean value we're going to use is 507. Now, to figure out the mean absolute deviation is we want to know how much does each one of these values deviate or differ from the mean. So you're going to take, and it's not about whether it's positive or negative, it's just how far from it is it. So we're going to say 505 minus 507 equals. That comes out to be a -2, but we're always going to take the absolute value. We're going to work in terms of positive numbers. So this value is too different. 510 minus 507 is equal to 3, and we're going to take the absolute value of that, so it's still 3. 480 has a difference of 480 minus 507 has a difference of 27. Okay, from 550, that's 43 different. 495 has a difference of 12, and 500 has a difference of 7. Now again, some of these are negative, but we're going to take the absolute value of these differences. We're always taking the absolute value. So we're not going to keep negatives, it's just always going to be positive. And now you're going to take these deviations and you're going to average them. So you're going to take 2 plus 3 plus 27 plus 43 plus 12 plus 7. And we get a value of 94, and because I'm averaging them, I'm going to divide by 6, and I get 15.67. We would call that the mean absolute deviation. It's what's the average amount that each one of these values is different from the mean. Now, obviously, this is going to change depending on what you round this to. I believe your worksheet asks you to round to the nearest hundredth. So if I had left this as 506.67, it would have changed these values up. You would have had to work with a decimal, but you would still follow the same process to find that mean absolute deviation. Okay? Give that worksheet a chance.